Hello, let's round up our AC and ventilation design. Let's get the floor area of this office. The floor area of this office is 12.21 meters squared. Let's multiply this value by our BTU per meter squared, which is 1785 times 12.21. So for this office we will require 21,794 BTU, which is reasonable. You can see this office, the south side is not being shaded by any corridor. It is gaining direct sun radiance from the south, which I told you the south is also another brutal side. As well, the east is exposed, so 21,000 is reasonable. But another challenge is we don't have 21,794 readily available in the market. The next higher capacity is 24,000 BTU, so let's go for the 24,000 BTU. There we are. So for this single split AC system, the outdoor unit, which is the condenser, and the indoor unit, which is a wall mounted split AC, in this case not a ceiling cassette now, are all of 24,000 BTU capacity. The outdoor unit is an ordinary outdoor unit, not a VRV and not an inverter, but the client can choose to use an inverter outdoor unit to save electricity. So but the capacity is 24,000. Now the next office, I'm cutting corners because I don't want to include this toilet. That is one good thing about this measurement tool. Yes, everywhere is covered. So for this office we have 16.17 meters squared. Meters squared multiplied by 1,785, 28,863 BTU for this office, which is also reasonable because of the south side is being exposed directly, as well as the east side. So but we don't have 28,000. The next capacity is 30,000 BTU, so let's use 30,000 BTU for this office. Again, for the outdoor unit, you can choose to use a VRV or an ordinary outdoor unit. inverter or non-inverter, but inverter is highly recommended just to minimize waste, because at times this office might not necessarily need this 30,000 BTU, maybe when the weather is cold. So this inverter motor outdoor unit, if that's what you are using, will give you the required airflow at that point in time. So now the next thing is to size our extractor fan in order to evacuate the bad air or polluted air of this toilet. So let's go to our calculation page and do that. Now for the toilet extractor fan sizing, according to the Chartered Institution of Building Services Engineers CIBSE Guide B2, it recommends that there should be 10 to 15 air changes per hour, meaning 10 to 15 batches of air should be changed per hour for public toilets. Also, the American Society of Heating, Refrigeration and Air Conditioning Engineers, ASHRAE 62.1, it recommends 10 air changes for intermittent use, meaning not a continuous use, like in our own case, which is a day school. This school, I don't think it's a boarding school, it's a day school. So you see, the use is going to be intermittent, not continuous. And 15 air change for continuous use, maybe for boarding schools for 24-hour use. So in our own case, let's adopt 13 air change. Let's be in the middle, 13 air change per hour. So now since we are adopting 13 air change per hour, we are going to require the volume of the toilet so as to size our extractor fan. Now let's go back to our design. Let's start with this toilet. Let's get the area. So the area of this toilet is 2.2 meters squared. 2.2 meters squared. So 2.2 meters squared. Is that what we got? Sorry, let's measure again. Okay, we got 2.02, not 2.2. meters squared, and if you remember, we proposed 3.5 meter for the height of our building. So now the volume of this toilet is 7.07 meter cube. Now ventilation rate, volume times air change, which we adopted 13, right? So 7 0.07 times 13, 91.91 So now we are having 91.91 meter cube per hour. We are going to adopt 100 meter cube. We are going to adopt 100 meter cube per hour for this toilet, this particular toilet. Now this is telling us that this fan is supposed to remove 13 batches of air in 1 hour, and the combination of these batches is going to give us a total volume of 100 meter cube. That is, if you divide 100 by 13, so it means for each batch about 8 air change will occur. About 8 meter cube, I mean, of air will be evacuated for each batch, and now we have 13 batch, so the total is going to be 100 meter cube per hour, according to the extractor fan we are adopting. So we are going to use this size for our toilet. Meter cube per hour wall mounted extractor fan. You can use GX6 or Expelia. Now let's size the next toilet. So for this toilet we are having 1.8 meter squared. Let's get the volume. 1.8 times 3.5, 6.3. Now 6.3 times 13 air changes, we are going to have 81.9. So for this toilet we can adopt 90 meter cube per hour extractor fan. Meter cube per hour wall mounted extractor fan. So let's size the next toilet. So for this toilet we have 2.0 times 3.5 times 13, which is 91. We are also going to adopt 100 . this we have the same 2.0, so no need to make calculation. We already know we are going to use 100. Now the last toilet on this floor, we have 1.8. We can say 1.81. So back to our calculation. .81 volume is 6.3. Meter cube, right? 6.34. Okay, let's use it like that. So now .34 multiplied by 13 air change, we are going to have 82.42 meter cube per hour. So we are going to adopt 90, which is the next capacity, 90 meter cube per hour. So for every hour, this extractor fan will evacuate 90 meter cube of polluted air. That is in 13 air changes. Alright, so let's copy this, because the toilets on our first floor are the same thing with the ones on the ground floor. So we can just delete this and then copy this. No need to repeat the calculation all over. Alright, so that is that for our AC and ventilation system. Now you can see the capacity of our air conditioning systems are a bit high, left to me, and this is so because we assumed the worst case scenario. Remember, our architect didn't furnish us with the schedule of the components, like the doors, the walls, the types of glass for the windows, and also we assume that for this conference room there is going to be use of electric kettles and fridge, which all this contributed to high cooling load capacity. So maybe this conference room might not necessarily make use of these electric kettles like we are assuming, or if they really need coffee, they will be making use of a coffee maker, which might not give out much heat, dissipate much heat like that of the electric ket. Also, not everyone will be charging their phone at the same time, and not everyone will bring in their laptop when there is a meeting ongoing. So you can see all these factors have contributed to us having a very big cooling load capacity. So another thing is, for the walls, we assume that there is going to be use of ordinary walls. The walls will not be insulated from direct radiation from the sun, meaning the wall will not be making use of insulated materials like reflective coating or paints, like use of foam boards to reduce conduction convection. Also, for the glazing, that is the windows, we assumed ordinary clear glass window. We did not assume the windows are going to be made of reflective glass, which will bounce back radiation from the sun. Also, for the door, we assumed the door to be made of Turkish steel, not a wooden door. A wooden door will not conduct much heat as that of Turkish steel. So all these assumptions we made contributed to this outrageous cooling load value. So that is why it's necessary you get these schedules from your architect in order to not over design. But for safety, our assumption is in line, and it will not harm, it will not be too bad. So that's that. Now the last thing is to bring in our air conditioning system detailing. Let's get that from one of our previous design. Let's copy to clipboard. So this is just installation details for our outdoor unit and indoor unit, wall mounted in this case. You can see this is the outdoor unit, the condenser, and these are the pipes, the refrigerant supply pipe, the return pipe, and the condensate pipe. You can see the condensate pipe is terminating outside, it's not going in back into the condenser unit, which is this. This is the detail: 25 mm diameter AC drain pipe to rainwater pipe, meaning you are linking it to a stormwater drain, or you are allowing it to fall freely on the floor, whichever way you do it. This is the height, the preferred height at which the wall mounted split AC is supposed to be from the finished floor level. You can see 2.4 meters height. You can either put it 2.1 meter height or 2.4 meter height. So this is 2.4 meter height is okay for efficient distribution of chilled air. If you make it lower than this, that is, if you bring it too low, the occupants will be exposed to direct chilled air, which might cause cold and will be uncomfortable for the occupants. So 2.4 meter height is okay. That is that. So this is the detail of the outdoor unit, which is the condenser. You can see this is the supply pipe for the refrigerant. This is the supply line and the return line as well. So that is that about our air conditioning and ventilation system design. Now in our next session we are going to look into the firefighting. Yes, that is the next aspect we are going to move into. That is the firefighting aspect. Now I think we can, okay, let's just call it a day. See you in the next session. Thank you for watching.